now let's look at problem 24. So then this is the third last problem we'll do, is it's up to 26. All right, so part A says, show that the Maclaurin series of the function f of x equals to x divided by 1 minus x squared is the summation from n equals 1 to infinity of f sub n times x to the n, where fn is the nth Fibonacci number. That is Fibonacci number defined as where you have f sub 1 equals to 1, f sub 2 equals to 1, and then the next ones is going to be fn equals to fn minus 1 plus fn minus 2. So you add the next, you add the previous two. For n is greater than or equal to 3. So hint, and we're given a hint to write this function f of x. Yeah, so x over 1 minus x squared equals 2, and this is just the Maclaurin series starting point. So c0 plus c1 plus times x plus c2 times x squared plus etc. where these are the coefficients. And then we're asked to multiply both sides of this equation by 1 minus x squared. And then part B, by writing f of x as a sum of partial fractions and thereby obtaining the Maclaurin series in a different way. Find an explicit formula for the nth Fibonacci number. Yeah, so correct that spelling mistake. Yeah, so which is quite fascinating stuff here. Alright, so let's take a look at the solution. Let's go over solution to A. So let's follow the hint given. And again, we're asked to show that this, the Maclaurin series of this f of x equals to x over 1 minus x squared is equal to this right here. Summation from n equals 1 to infinity of fn times xn, where fn is the Fibonacci number. And then, yes, we're asked to write this and multiply both sides by this setup over here. Alright, so let's follow the hint. So what we're going to do is, well, we're going to let this part right here, that's just f of x, and this is the Maclaurin series. So we're just going to let it equal to it. Let f of x is equal to, where f of x is, we're given this is 1 minus x squared. Let it equal to the Maclaurin series. So the starting point n equals to 0 of just the power series right here, where a, this is just Taylor series, or just the power series, where x minus a, where a is 0. So we have this equals to, when you plug in c0, we get c0 plus c1x to the 1 plus c2x2, c2x2 plus, and then one more plus c3x3 plus ... Alright, so here to move things around, made it more compact. So we have this like that, and then the hint says multiply both sides by 1 minus x squared, or in other words, just move this over to the other side. So let that, then what we'll have is we'll have x is equal to, again, move this over to the other side, x is equal to 1 minus x squared times by c0 plus c1x plus c2x squared plus c3x cubed plus ... and then all like that. Alright, so now remove this, and now we're going to multiply this inside, basically multiply this all out, or just expand it all out or FOIL it out. So we're going to multiply this 1 by this, by that, etc. And then same thing for the negative x and so on. So what we end up getting is, well, pretty much 3 series. So we're going to have, when you multiply 1 by everything, we're going to get the same one. So we're going to get c0 plus, plus c1 x plus c2x squared plus, and then I'm going to go all the way to the x5, c3 x3 plus c4 x4 plus c5 x5, and then plus ... This goes to plus ... And here I just made it more compact here, and so that's the first one, and then the next one is going to be negative x multiplied by c0. So this one doesn't have the coefficient without the x there, so we can ignore that. It doesn't have the x to the power of 0 side. So we'll line it up over here. So this can be negative c0x And the next one is going to be negative. It's going to be negative on all of them. But then there's a c1x minus x right here. That'll be negative c1x squared. So this is going to be c1x squared. Notice the pattern. The next one's going to be minus c2x cubed. And then plus, it's all going to be minus c3x4 minus c4x5. So notice it's off by 1. Just 4, that's 5, etc. And then minus dot dot dot. Keeps going on and on. Then the next one is the next one is x squared multiplied by it, or negative x squared. So negative x squared, we'll line that up with this x squared over here. That's going to be negative c0x squared. And then the next one's c1. Yeah, c1 there. Let's put this like that. Multiplied there. c1, negative c1 x cubed. So you can see the pattern there. And then it's going to be again c2x to the 4 minus c3x to the 5 and minus dot dot dot. So we could see the pattern here. And then sum this all up. Yeah, we could sum all this up. We could just view it kind of like a summation right here. I'll put it like this. What we get is x is equal to, well, this c1, or we'll just remove this line actually. I'll just remove this out of there. Alright, so yeah, what we'll do is I'll just drag this down. So we're going to drag this down here. This becomes, and then we'll have an arrow here. So this is x is equal to c0. And now add these two together. So add, just factor out the each of the x terms. This is going to be c1 minus c0 x. And then the next one is all these line up over here. This is going to be plus c2 minus c1 minus c0. And that's going to be x squared. And likewise over here, it's going to be plus, you can see the pattern now, c3 minus c2 minus c1 x to the 3, and then plus dot dot dot. So you can see that pattern. Alright, so now that we have all this, and notice that this whole thing equals to x. So in other words, we're going to have to cancel out all the x squareds and even the constant right here. This has to be 0. Otherwise, it's not going to equal to x. So basically, we're going to compare. So comparing coefficients of powers of x. That is comparing the powers on the left side, which is x to the 1. That's all there is, x to the 1. With the right side gives us, so the only one that's not 0 is a c1 minus c0 is the combination is not equal to 0. So what that means is, well, we know that c0 has to be 0 because there's no coefficient on this side. So this one has to vanish. And then we also know that this right here has to be equal to 1, so that we have 1x to the power of 1. And so we have that, and we have c1 minus c0 equals to 1, and we know that it basically solve for c1 by moving the c2 on the other side. So what we get is c1 is equal to 1, or just put a c0 in front, equals to, this equals to c0 plus 1. In other words, this just equals to 1. Because we know c0 is 0. This equals to 0 plus 1 equals to 1. And then likewise, this right here, the coefficient, there's no x squared, so these have to cancel out. So what we get is c2 minus c1 minus c0. This is equal to 0. Yeah, so that means c2 is going to equal to, we'll move this over to the other side. Yeah, moving this over to the other side, that becomes, well, that becomes all positive. This just becomes c1 plus c0. And this equals to, well, c1 is 1, and then c2 is 0. c0 is 0, so this equals to 1. Alright, and now the next setup is, you can start seeing the pattern. The next one here, c3, so do this better arrow. Like that. Then there's c3 minus c2 minus c1 also is equal to 0 because there's no x cubed on the left side. So we get c3 minus c2 minus c1. This equals to 0. Again, move these over to the other side. We get c3 is equal to c2 plus c1, which equals to, well, 1 plus 1. equals to 2. And again, you can keep doing this on and on. It's going to be the same thing. Dot, dot, dot. We're going to get a Cn minus Cn minus 1 minus Cn minus 2 equals to 0. And then move this around. We're going to get a Cn is equal to Cn minus 1 plus Cn minus 2. And this is for, this is for n is greater than or equal to 3. And we'll make it for this right here, and this is because, this is because, well, we have this one here, the C1 is actually equal to 1 plus C0. So, actually, technically, this is still true for n equals, n is greater than equal to 2, because you can see here, this is C1 plus C0. Yeah, this is actually, this is true for this too, but the thing is, we're asked to show that it's equal to this setup here. Yeah, so I just made it match this, or the solutions manual just makes it match that, and we'll put this here, or n is greater than equal to 2. So yeah, it doesn't matter there, but just to match up with our our given hint there, or not given hint, given, well, pretty much a hint. Yeah, given that this Fn is the Fibonacci number, just match with the Fibonacci. Yeah, not the hint. Yeah, so continuing further, so thus, each Cn is equal to the nth Fibonacci number. That is, we could write this as summation from n equals 0 to infinity of, so we've solved Cn, so this Cn is just a Fibonacci number. This equals to the summation from Cn xn. This is equal to the summation from n equals 0 up to n equals 2. I'm going to start from 1, and this is since C0 is equal to 0. So we just ignore that C0. Yeah, ignore the C0, because if you see above here in the Fibonacci number, there is no 0. We just ignore that. So there's no f of 0. Just start from f of 1 is 1. This just becomes redundant. Alright, this becomes Cn xn, which equals to the summation up to infinity of, from n equals 1 of fn x to the power of n, like that. Yeah, so that is what we got, and we can box this whole thing there. Alright, here, so we just boxed it in, and that is the question A. So we showed that the Maclaurin series for that function, this right here, the Maclaurin series of it is equal to the summation from n equals 1 to infinity of the nth Fibonacci number times x to the n, which is quite amazing. All right, let's go further, and now let's look at question B. So question B says, by writing f of x as a sum of partial fractions and thereby obtaining the Maclaurin series in a different way, find an explicit formula for the nth Fibonacci number. So this is where things get a bit interesting. This is pretty amazing. You can actually find the exact formula for this nth Fibonacci number. So solution to B. Let's start with completing the square of the following equation. And this is basically finding the square for this f of x function here. So this right here, 1 minus x squared, just to illustrate how we can get some factors out of there, because we're going to write partial fractions. So first, recall completing the square just means, recall that completing the square just means writing a function like this, x squared plus bx, so we had like this, plus c. I'll write b and c there just because typically there's an a there, but in this case we don't have anything in front of the x. This is a negative one, we could just make it all negative. So this equals to x plus d. So the idea is to make it into a square. So like that, x plus 2 squared, where this equals to x plus d times it by x plus d. And if you FOIL this out, we're going to get a scenario such as x squared, and then plus, now if you multiply, so x times x squared, x times d is xd, or dx, and then d times x is dx, and then d squared. So in other words, you're just going to get a 2dx, when you sum those up, plus d squared. So then the idea is, well, this b, So this right here has to match this. So that means that we have b is equal to 2d. And then this right here has to match this right here. So in other words, c is equal to d squared. Yeah, so b equals to 2d, c is equal to d squared. All right, so in our case, so that's what we have. So now what we're going to do is recall or consider in our case negative of 1 minus x squared, and write this as equals to, well, equals to the negative x squared becomes positive, plus x squared plus x, and then we just have a negative 1. So consider this right here. So this right here has its b is equal to 1. So we have b is equal to 2d, which equals to 1. So in other words, solve this over, we get d is equal to 1/2. So if d is 1/2, then the c has to be, well, d squared, so 1/4. So, or 1/2 squared. So in other words, if that is that, so then we get our c is equal to, this is right here, but yeah, this is not c. That is, well, yeah, it's obviously not c. So our c is supposed to be, c is equal to c is equal to d squared, I mean. So we know what d is. C equals to d squared, which equals to 1/2 squared, yes, square all that, which is equals to 1/4. And this is not equal to negative 1. Yeah, so it's not equal to negative 1, so it's not equal to this. So what we'll do is plus and minus a 1/4. So plus 1/4 minus 1/4. Yeah, so then that means then this and this is completing the square, where the square is going to be over here, x plus d all squared, where d is 1/2. So thus what we'll have is negative, yeah, that's what we have. Well, not negative, because we already solved that over here. Thus x squared plus x minus 1 is equal to, now this is going to be, again, when we add 1/4 and then subtract 1/4, we're not changing anything. That's just cancel out, it becomes 0. So this becomes, and now I'll write this out as x plus 1/2 squared, because we complete the square. So that part is equal to x plus d squared, where d is equal to, equals to 1/2. Yes, in other words, this is our d equals to 1/2, like that. And now this is going to be, yeah, so we have this, and now this minus 1 and this minus 4, we can add those up. 1 is just 4/4, that just becomes minus 5/4. Just skip the step, just do that. Alright, so that's what we have now. And then going even further, what we'll notice, well, what we can write is write this as a square. So this is a square here. Now we can write this as a square. So then we can have some more, basically, algebra here. So what we'll have is this equals to this equals to x plus 1/2 squared minus, this is equal to, I'm going to write this as square root 5 over 2 squared. So square root 5 squared is just 5, and then square root 2 is just 4. I mean, the square of 2 is just 4. So we're not changing anything. And now what we'll do is recall whenever you have a scenario such that you have a squares, recall that if you have a scenario such that you have a plus b times it by a minus b, that's where we get cancellations. So when you have this square and there's a square, this equals to, when you multiply this out, so this a times a is a squared. So that's an a squared. And then a times negative b is negative ab. And then you're going to have to do that with this over here. Plus b times a, that's just plus ab. So in other words, those will cancel. And then you're left with plus b times negative b, that's going to be negative b squared. So in other words, we could write this as this. So that is an interesting setup. All right, so that's what we have is, I'll write here as thus. Thus, this whole thing becomes, well, this first, right, let's write the beginning one. X plus x minus a is equal to, well, this squared, that means we can put this, if this is a, the inside. So that's a is the x plus 1/2. So this is our b. This is our a. And again, not to be mistaken with the b over here, but this is just over for this setup here. Or better yet, I'll remove this and remove this. Let's go back. Okay, I'll just delete this like that. Delete that. I'm going to put this arrow right here. This a is on the other side. So this is our a, and then this is our b. So that means, well, we can write this as this setup here. Instead, we'll write a plus b. So this will be x plus 1/2 plus b plus square root 5/2 times it by, and then times this by x plus, so that's a minus b. So minus square root 5/2, like that. And this can add these up, and we're going to get a scenario. Just add those same common denominator, x plus 1 plus square root 5/2 times it by x plus 1 minus square root 5/2, like that. So that's what we have. And so now we have factors of this x squared plus x minus 1, which is, again, that's just the same thing as negative. That's a negative of this, 1 minus x squared. And then we have our, that's our f of x. So this is this part right here. So we'll have a negative x over those factors. And then we can write these as partial fractions. All right, so now we can write out f of x as, so let's write this out. So f of x is equal to x over, and this was 1 minus x squared. But now take out a negative, this equals negative x over x squared minus x minus 1. And then this equals to negative x over our factors. X plus 1 plus square root 5/2. And then times it by x plus 1 over square root 5/2. I mean minus square root 5/2. Like that. And here I just moved things around, just made it more compact here as well. So we have this, and now the factors in the denominator here are linear, so the partial fraction decomposition is, and it's linear, so in other words, there's no x squared, x cubed, etc., or square roots, or anything like that. We just have x to the 1. This is the highest power of x. So what we get is, we could write this in partial fraction decomposition form. So let's just write this out. Negative x of x plus 1 plus square root 5/2 is equal to, times it by, at the bottom, the x plus 1 minus square root 5/2. This equals to, alright, so this equals to, so now we have those factors, so so in partial fraction decomposition, it just means, well, if you have factors like this, you're going to have something that creates them that are composed of each separate factor. So this could be written as a over, pick the first one, a over x plus 1 plus square root 5/2. And then the next one is, well, we don't need a bracket because nothing else multiplying, plus b over just regular like that. Yeah, over bx plus 1 minus square root 5/2. And now what we'll do is, well, multiply both sides by this. So multiply it or move it over on the other side, and we're going to get a bunch of cancellations. So we get negative x is equal to a, and then these ones will cancel. So this will cancel, and we're left with this x like this, x plus 1 minus square root 5/2. And then plus on the b side, this one will cancel with this. So we're left with b, or we're not dividing, so put it here, b times x plus, so this will cancel, we're left with the positive one. 1 plus square root 5/2, like that, and square root 5. Alright, so now that we have this, what we could do now is, well, we could write if if x, so right here, we can get rid of this a by writing x equals to the negative of this one. So if x equals to -1 plus square root 5 over 2, yeah, then what happens is, well, a vanishes. So then this becomes 0, that gets out of there, and then we're just left with b. So then we can solve for b. So we get a negative of this, so negative of -1 plus square root 5 over 2 is equal to b, b times, and then we'll have inside there -1 plus square root 5 over 2, and then plus 1 plus square root 5 over 2, and then all bracket like that. And now we could just simplify this, or better yet, just cancel all the 2's. There's everything, there's a 2 everywhere, divided by 2. So cancel all that, and then get rid of this minus, and then this one becomes negative. So this becomes 1 minus square root 5 equals 2. So let's put another arrow. Let's make it like this. This becomes, 1 minus square root 5, and then we have a b right here, and then this right here, well, this same common denominator, well, those are all canceled anyways, and then this subtracts, so we have a -1 plus 1, that cancels, and then we have 2 of these square root 5s. In other words, we get, put that in front actually, 2, and then times it by square root 5 of b. So this means that b is equal to 1 minus square root 5 over 2 square root 5. And I'll just box this in. Alright, so that's for that. I'm just going to put a line here so that just to show that we are doing ifs now. So let's solve now. So that's if x is that. Now if x is equal to, we'll make the b vanish now. So if x is equal to negative, right here, 1 plus square root 5 over 2. Yeah, so we'll put that in. So if x is equal to -1 negative square root 5 over 2. So the difference is this was -1 plus, because there's a negative there, square root 5 over 2. This one just becomes negative. Like that. If it's that, then what we get is, well, b vanishes. B vanishes, so this becomes 0. And now we're just left with this a right here and this negative x. So we get negative x, which is, well, x is here. Negative of -1 minus square root 5 over 2 is equal to a times that. So equals to a times it by, and put a bigger bracket, times it by negative, so this is going to be our x, plus 1 minus square root 5. So this is going to be -1 negative square root 5 over 2 plus 1 minus square root 5 over 2, like that. And all the 2's cancel, as always, so that cancels. And then get some simplification. This becomes, all these negatives cancel, it becomes 1 plus square root 5, and this equals 2. And now this -2 plus 1, -1 plus 1, those cancel. And now we're left with a negative square root 5 and a negative square root 5. So that means there's 2 square root 5s, but they're both negative. So we'll get a -2 square root 5. Let's make it so it's not like the 2 is the square root number. This is, -2 times square root 5 of a. So in other words, a is equal to, so a is equal to 1 plus square root 5 over -2 square root 5. Let's put the negative on the bottom there, just because the solution manual did that too. Alright, like that. So we can box this in. Alright, so thus putting this all together, we get, and I'll just put a line, thus, we get our x over 1 minus x squared. Remember, this equals to our, if we go back up, it equals to, scroll above here, so we have x over 1 minus x squared. 1 minus x minus x squared equal to negative x over x squared minus x minus 1 equals all this, where this equals to a over this, partial fractions. And now we solved for a and b, so we can write it over this. equals to a, which is 1 plus square root 5 over negative 2 square root 5 all over, and then the a, over this one here, x plus, and then this is a plus, 1 plus square root 5. So this is going to be x plus 1 plus square root 5 over 2, like that. And then this is going to be plus, this is our a, so this is our a right here. I'll just put this here. Or we can get rid of the line then. This could be our a right here. This is our a. Then plus, now our b is going to be equal to 1 minus square root 5 over 2 times square root 5. So 1 minus square root 5 over 2 square root 5. And this is our b. Like that. I'll draw this, the other one, this parentheses sign. So this whole top numerator is a and this one's b. And this is over x plus, the other one's going to be 1 minus square root 5. Yes, we remember this. Over 2, and let's just double check that quickly. And yeah, there is right over here. So x plus 1 minus square root 5 over 2. So that's what we have there. And here I just move this down a bit just so I can draw this line, this separator line, just so that we are onto this now. And now what we can notice is, well, in this top part we have this 1 plus square root 5, and this bottom has a 1 plus square root over 5, and there's also a 2, there's also a 2. So what we'll do is multiply the top and bottom of this by 2 over 1 plus square root 5, and in this one, same thing, but instead of plus, we'll do a minus, because there's a minus square root 5, there's a minus over there. So what we'll do is write this as equals to 1 plus square root 5 over negative 2 square root 5, divide this by x plus 1 plus square root 5 over 2. Alright, yeah, so here I just made it a bit smaller. I'm going to multiply now the top and bottom by 2 over 1 plus, write this neater, so 2 over 1 plus square root 5, then divided by 2 over 1 plus square root 5, like this. So then what happens is, well, this cancels, this cancels, this cancels, and then this whole part cancels, it becomes 1, and then we'll do that after. Also this cancels. So what we get is there, and the next one is if we look at this one here, let's write that 1 minus square root 5 divided by 2 square root 5 over like this, over x plus 1 minus square root 5 over 2, yeah, like that, and then multiply this one by 2 over 1 minus square root 5. And then this is 2 over 1 minus square root 5, like that. Let's write this a better 5, like this. Alright, so then what happens is this whole thing cancels, this cancels, or not the whole thing, just a 2 cancels. 2 cancels, yeah, 2 cancels, and then this whole part cancels, this cancels. And now this one cancels with this part here, and then what we're going to be left off with is equal to, yeah, equals to, well, this one we're just going to be left with the 1 over negative square root 5. So this is going to be negative 1 over square root 5. Negative, just move the negative out of there. And then divide this by, this right here becomes, yeah, this becomes, and I'll write this, I'll multiply this one in first. I'll move that here, plus, and then we'll have an x, x, or 2x. We'll have a 2x over 1 plus square root 5. That's on this side here. And then plus, the next one here is going to be 1 over square root 5. 1 over square root 5, and again, move the 1 in front, because this all cancels, and we're going to left with a 1, move that in front, 1 plus, and then a 2x, 1 minus square root 5, like that. So that is what we have so far. And here, let's move the 1 over 5s down, or 1 over square roots down. We'll move this, I'll call this right here, negative 1 over square root 5, like this. Yeah, times it by 1 over 1 plus 2x over 1 plus square root 5, like that. All right, here I just move that over to this side here because we're going to need more space. And then the next one's going to be plus 1 over square root 5. And the reason I'm writing it like this is, well, if we notice, we have two geometric series right here, actually. So 1 plus 2x over 1 minus square root 5, like that. All right. Alright, so now, yeah, notice that, or note that the above two fractions are in the form of the sum of a convergent geometric series. In other words, this right here is the sum of a geometric series, and this is 2. Because you have that 1 minus 1 divided by 1 minus r. Like that. And this. So this means we can write them as a geometric series. So again, recall geometric series. If you have the summation infinity like this, yeah, this equals 0 from n equals 0 up to infinity of arn, where this just equals to, remember, a, so n is 0, then plus r, n1, ar1 plus ar squared plus dot dot dot. This equals to just 1 over 1 minus r. And this is 4, absolute value of r is less than 1, like that. And here, just put that in there right here. So absolute value of r is less than 1. And in our case, what we get is, yeah, so I'll put that in here. So thus, in our case, we have x over 1 minus x squared is equal to, well, remember this part right here, that's the sum of it. So x over 1 minus x squared is equal all to this. But now let's write this as a sum of a geometric series. So this equals to negative 1 over square root 5, and then times it by the sum of, from n equals to 0, of now r, well, ar. So in this case, we have a is 1. So in both cases, we have a is 1, and then r is negative of this. So this is going to be a negative 2x over 1 plus square root 5 to the n, which is quite fascinating. So we can write that as a series. 1 plus square root 5 over to the power of n. All right, so in both of our cases, we have a equals to 1. And here, this is our r. That's the r for this case. And then the next one is, this is going to be now plus 1 over square root 5. This, yeah, it's just a constant over here. Times it by the summation up to infinity from n equals to 0. And then this is going to be, a is also 1. And then this one's going to be negative of this one. It's going to be our r. So negative 2x, so we'll put 2x, yeah, negative 2x over 1 minus square root 5, like that. And then, yeah, that is our negative r, yeah, that's our r right here. So this is our negative r, let's put a negative there, and this is going to be n, and this whole thing is our r. So there's our r for this case. So we got two series there. Alright, so now that we have this, we can simplify this by combining the series all into 1, and still factor out the 1 over square root of 5, but move this in front and then make this subtracted inside there. So what we'll do is this equals to 1 over square root 5, and then summation up to infinity from n equals to 0 of, and then move this forward because it's positive and this one will be negative. So we're going to have, and also factor out the x n. I'm going to factor out the x out of there, so that's going to be both x to the power of n. So we'll have a giant function like this, negative 2, actually no, 2 is on the front. Actually no, this is correct, yes. So we'll have a negative 2 over 1 plus square root 5, and just put the bracket around. This is going to be power of n. And actually we're going to do this one first. This can be, because this is positive, so it's positive right there, and then we'll subtract it by over here, so that's a negative 1. So subtract it by, and then this is going to be negative 2 over 1 plus square root 5, and that's what we have here. And what I'm going to do is, it's power of n, and then this is all times it by, so we factor out the x to the power of n there, like that. Alright, so now that we have this, we can do some more simplifications, and I'm going to write this as equals to 1 over square root 5, and then again times it by summation up to infinity of, I'm going to start from 1, because when you put in n is 0 here, this becomes 0, this becomes this to the power of 0, which is 1, and this one becomes 1 minus 0, and this is all, then this one is just 1. So in other words, we get a scenario of, I'll just put it here, I'll say n equals 0 term is 0. In other words, we get a scenario of 1 minus 1 power of n, 1 to the 0 power of 0 equals to 0 there. So we just have it to the 0 there. Or I'll just have this this to the power of 0. I'll just have a number 0 minus number 0, like that. And it all goes to 0. So that's this part right here to the power of 0, and everything else is 1. And this one will just vanish because you're multiplying it by 0. So that is the power of 0, like that. And now what we'll do is, we're going to multiply the top and bottom to get the same common denominator, and also multiply this n inside, and just do this all in one go. It should be pretty straightforward, especially if you've gotten this far in the video. You should do this in your sleep. So this will be the bottom. Is we're going to multiply, to get the same common denominator. So I'm going to multiply this top and bottom by 1 plus square root 5, and then this one times it by, and then to the power of n, and this one multiplied by top and bottom 1 minus square root 5 over, on the top and bottom. So this becomes 1 minus square root 5 times it by 1 plus square root 5, and then this is power of n. This is n, power of n, like that. Alright, just fix that up, and now this one here, we're going to have a negative 2n, and then the top's going to be the other one that doesn't cancel, and that's going to be 1. Actually, no, we don't actually cancel anything. It's just going to be just this part right here. Because we're getting the same common denominator. I'm just skipping a step. Just to, otherwise, this will take us forever. So this will be like that. And then minus, again, negative 2 to the power of n, times it by the other one, which is this one here. We're multiplying top and bottom. So we get the same common denominator. 1 minus square root 5, like that, to the power of n. And then all of this is going to be multiplied by x to the n. And now, continuing further, I'm going to factor out this minus 2 to the power of n out of there. So this equals to 1 over square root 5. So put the negative here. Oops, erase it. Square root 5 times it by the summation up to infinity from n equals to 1. And then we'll factor out the negative 2n. And then this is going to be multiplied this by... And I'll see, just to get different, I'm going to put a bracket like this. Like that. Or actually, let's put a giant bracket. Alright, and now we're just going to factor it out. This is going to be 1 plus square root, like this. Put that bracket inside, power of n. 1 plus square root 5, power of n, minus, and we factor out this negative 2 to the power of n out of there. And this is going to be now 1 minus square root 5 to the power of n. Close that bracket. All divided by, now this one here, this will equal to negative 2 to the power of n times it by 2n, and I'll illustrate that in a bit, and then times it by x to the n. And I'll put a note here, note, or put this here, right here, note, actually, this takes too much space up, I'll just put a note here. Note that, so if we look at this one here and FOIL it out, we get 1 minus square root 5 to the n times it by 1 plus square root 5 to the n. This equals 2, you could just write this as bracket 1 minus square root 5 times it by 1 plus square root 5, and then this is all to the power of n, like that. And then we could just FOIL this out, so 1 times 1 times plus 5, and then this one here and this one here will cancel as per earlier. So what we're going to get is this equals to 1. Let's for completeness, so erase this, equals to 1, 1 times 1, and then we're going to have plus square root 5, and that is, 1 times square root 5. And then we're going to have over here negative square root 5 times 1. Yeah, so let's write this. Negative square root 5 times 1 is going to be negative square root 5. And then negative square root 5 times times plus square root 5, that just becomes plus 5. Or negative 5, actually. Yeah, negative 5. The square roots cancel, because that is just squaring it. So then this cancels, and again, this is all to the power of n. I'll put a giant bracket here. Power of n. So this equals to 1 minus 5 to the power of n, which is, I'll just put it for completeness, 1 minus 5 to the power of n, which equals to negative 4 power of n, which equals to, I'll just write this here, so because we want to cancel negative 2n, so this is going to be equals to negative 2 times 2, and this is going to be, or negative 2 times 2, just like that. I'll just put it negative 2 like that, power of n, which equals to negative 2 power of n times by 2n. And this is what we get here. Yeah, so this is this right here. Is this one. I'll just put is this. So that is this. Like that. And then we can do a bunch of cancellations there. So wrote it like that so we can do some cancellations. So this will cancel with this. So all that is to cancel. Alright, so thus, put it all together, we have, so thus, this whole thing, remember, is just equal to x over 1 minus x squared. That's our f of x. So what we get is thus, and bring this down, thus we get x over 1 minus x squared is equal to 1 over square root 5. Yes, 1 over square root 5, like here, times it by the summation from n equals 1 to infinity of this whole thing. That all cancels out. So what we're going to get is, it's just that this is 1 plus square root 5 to the power of n minus 1 minus square root 5 to the power of n, and then divided by 2n. So we just need one bracket like that. 1 plus square root 5 over n minus 1 minus square root 5, like this, power of n. Alright, let's erase this. All over 2n, to the power of n, because we cancel that negative 2n out to the power of n. Divide this by, times it by x to the n. Yeah, so that is what we have here. And this series right here, well, this is just our f of x now. And if we recall how we solved it in part A, so we scroll all the way to part A, we got it over to here. So we wrote it as a Maclaurin series, and it equals to summation from n equals 1 to infinity of fn times x to the power of n, where fn is the nth Fibonacci number. And again, so if we go back to the question, that's what we had for here. So this one, f of x equals to, is this. So we showed that it's this. And that was just the Maclaurin series. So, so we wrote the Maclaurin series out, we wrote it out. So in other words, this right here is equal to the summation from n equals 0, from n equals 1 to infinity of fn, which is the nth the nth Fibonacci number, and this is from part A. So that's from part A. This is that's just our f of x with a better summation symbol. Yeah, so since this series is equal to that from part A, it means that we have an explicit formula of the nth Fibonacci number, or explicit formula for the nth Fibonacci number. And that is actually quite amazing. So hashtag amazing. So now this needs to equal to all of these coefficients there. Yeah, so we'll just have to put this 1 over square root 5 back inside. So then this means that Fn is equal to, and this is going to be all of the inside. So let's write this out. This is going to be 1 plus square root 5 to the power of n minus 1 minus square root 5 to the power of n. All this divided by 2n times by square root 5. To bring this fraction back inside here. And that is our explicit formula for the nth Fibonacci number, which is quite amazing. So this is Fn is equal to this, and we can box this out. Alright, so now that we have this, and now we can do a quick calculation check to make sure it's actually correct. So here's the first 6 Fibonacci numbers. So they are, so you have the 1, so the first one is just 1, second is 1, then you start adding up. Then you have 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, then 5 plus 3 equals to 8, and this is the 6th one. So this is 1, 2, 3, 4, 5, 6. So calculating the 6th Fibonacci number, let's put it like a 6th Fibonacci number yields, so we'll have F6 is equal to, and let's put this all in there. So we have 1 plus square root 5 to the power of 6. So here's this right here, to the power of 6. 1 plus, square root 5 to the power of 6. So in my OneNote calculator, you can just write SQRT, and then subtract this by 1 minus square root 5. So 1 minus square root 5, and then to the power of 6. Then all divided by 2 to the power of 6 times square root 5. And if you plug this in, what we get is, well, let me just delete this. And then press space, automatically calculates. And then here rounds up, calculator rounds during calculation, so this is correct. So this equals to 8. And this is 8.001. So yes, so that's an error. But yeah, so it's 8 is correct, which is quite amazing.